The very first thing that we have to work on is going to be the character class. This is going to be a parent class because the player and the trainers share a lot of data. They have the same texture, collision, movement, animation, and quite a few more things. As a consequence, they should both inherit from the same parent class. That is going to make the entire project much more efficient. And from the parent class, for now, we're going to start creating the player. Let's jump right in. We first have to create a 2D scene that I want to rename to level. This I want to save inside of a new folder for scenes, in which I want to have another folder called levels. In there, I want to save level.tscn. This is going to be the basic platform for the actual level. Inside of it, I want to have two children. The first one is going to be a node 2D called background. This I want to duplicate because next up I want to have, let's call it the objects. Inside of the objects, I want to have another node 2D for the characters. That way the entire thing is nice and organized. That means now we can create the actual character, which for now is going to be a new scene where the root node is going to be a character body 2D. We can rename this to character right away, save it inside of a new folder for characters, enter there character.tscn, save it. Then I want to zoom in just a bit and create two more nodes. The first one is going to be a sprite 2D, for which for now I want to go to graphics, to characters, and then get character.png. Drag this into texture, and then we get something that's barely visible. Because the background doesn't really work with it, but if you zoom in, you can see we have the outline of a character. Although at the moment, this is an animation, and we only want to see a single image. You want to go to animation and set H and V frames both to 4. That way we only see one image of the character. Besides that, I want to add a collision shape 2D. For the shape, I want to have a capsule shape that I'm going to resize to something like this. Does not have to be too precise. This would be alright. With that, we have a basic outline for the character class. From this, we're going to create the player, which means I want to go to scene, new inherited scene, character.tscn is the parent class, click on open. Then we have a new scene where the root node should be called player. This I want to save as well, inside of the same folder. And then we have the player. This is actually going to be visible inside of level. So I want to attach the player to characters, and then we are getting something. Barely visible at the moment, but at least we have something. This we now need to customize, for which I want to add two scripts. The first one goes to the character. So attach a script here, the defaults are fine. This I want to save now, and the player is also going to get a script. But this we can't do right now, because the player inherits the script from the parent. This I want to get rid of, so attach the script, and then add a new script, where we are getting the player. The issue we have now though, is that the player has its own script, so whatever code we are writing inside of the character class is not going to be inherited. To fix that, you want to give the character a class name. At the top, you want to have class_name, then the name of this node, let's call it character, and then we are extending a character body 2D. This is effectively adding a new node to Godot. If you attach a new node to anything and you look for character, then we have a new node that inherits from a character body 2D. So in other words, any kind of function that we are going to write in here can be inherited. Which means inside of the player, we don't want to extend a character body 2D, we want to extend a character. Which means that whatever code we are writing inside of the character is going to be available inside of the player. On top of that, for the player, we also get the sprite 2D and the collision shape 2D. Perfect. With that, we can start with the actual logic. And just to make sure that we can see something, I want to export a variable, which is going to be the character style, or how the character is going to look like. For this, I only want to allow a certain data type, which we are getting from data, The global file, so data.gd, is global because inside of project settings, and globals, we have data. And the character style is defined by this enum dictionary, where we have all of these possible styles, and they link to a character texture data. All of this. One of those we want to select and then load the graphic once the game is ready. That means inside of the character, for character style, I want to have data.character style. If you now go to the level and select the player, you should be able to select the character style, but you are not able to. That is because when you have the node inside of the scene tree and you add a script to it via inheritance, then this is not going to be updated. For that, you want to remove the node and then reattach it. So I want to attach the new player, and now the player has a script. Kind of an annoying behavior, but it's quite easy to fix. Now that we have the player, we can select a certain kind of style. I want to go with player, but you could choose any of them. That being said, we have to use the data. For that, once the scene is ready, which means func_ready, I want to get from the character sprite 2D node the texture. And the value I want to assign to it is going to come from data, character texture data. This once again, we're getting from data. And in there, the key is going to be the enum that we have selected. And the value is then going to be the path that we want to load. This is going to be the dictionary. From this dictionary, we want to get the value that we have from the character style. This is going to return a path that we want to load. And with that, we should have the right starting value for the player. If I go to the level and move the player vaguely here, I can run the current scene, select current, and then you can see it in the top left. We can see the player. Very small at the moment, but it's something. I suppose what we should also be doing to the player, we want to add a camera 2D. I have set the zoom level to a factor of 3 for X and Y. That way, if you're running the entire thing again, the player is much more visible. Now, just to have something for the player, I want to be able to move the player around, for which I want to work inside of player.gd and add func_get_input, where at the moment I want to get input and get vector. That way I'm getting the 4 directions, where I want to have left, right, then we need up, and finally we're going to need down. That covers all the 4 directions that the player can move in, but this we have to store. Ideally, I want to have something like direction is equal to what we have gotten from the input. This direction, however, will be used by the player and by the trainers, so it should be inside of the character class. In there, I want to have var direction, and this should be a vector 2. Once you have that, inside of the player, Godot should stop complaining, so we are getting input. And to make sure that this is working, I want to add func_process call get_input and then print the direction of the player. If I now run the entire thing, I can press right, left, up, and down, and we're getting values. So we are capturing user input that we can then use. To actually implement that, I want to add another function called move. And like before, this function will be used by the player and the trainers. So it should be inside of the parent class. Func move, which is going to be fairly simple. All I want to do is update the velocity and set it to direction multiplied by some kind of speed. Speed at the moment doesn't exist, so we can create it. Var speed is going to get a value of 60. You could refine this for the player and for the trainers, but I think we can keep it simple and just have a constant value. I want to call move and slide, so we actually use the velocity, and then inside of the player, once we are saving everything, and we can add an underscore to delta time, then this should be working. Let's try. If I now run around, you can't see anything. But that is because we don't have a background. Everything behind the player is a constant color, so it doesn't matter where we move, it all looks the same. You want to select background and then add a tile map layer. I just want to have something in the background so we can see player movement. That means I want to go to tile set, create a new tile set. The defaults here are totally fine, 16 by 16, and the tile shape should be square. After that, you want to go to tile set and add from tile set overworld.png. This covers most of the worlds, and for now, I just want to add a basic grass patch. To add that, you want to go to tile map, select it, and then paint something behind the player. If I now run the game again, I have something in the background, and if I move around, you can see that the player is actually moving. So that's a pretty good start. Next up, we can work on the animations. Let's work on the animation. We either have the player standing still or walking. Those are the only two states. The same is going to be true for the trainers, and that's kind of all we need. Now for this kind of thing, you could create an animation player and an animation tree, but that's going to be overkill. We're going to write some basic code. That is all we need to manage this entire thing. Back inside of Godot, since we want to have animation for both the player and the trainers, I want to work inside of the character class. I want to have another func for animate. This one is going to need delta time. And for now, let me add pass in here, because we have to talk about what we want to animate. If I add one of the character graphics, like the blonde character for example, fundamentally we have 4 animations: going down, going left, going right, and going up. The first frame for all of this is going to be the idle frame, where we can stand and look in 4 different directions. If the player is walking down, I want to get this frame, this frame, this frame, and this frame, and then go back to the start. If the player is going to the left, then I want to get this frame, this frame, this frame, and this frame, and play them continuously. This we have to implement. For which, first of all, I want to check if we have a value for direction in the first place. If the player is not moving, we don't have to animate anything. After we have that, I want to get, let's call it the face direction. If we are moving, I want to know in what direction the player is facing. The data type is going to be a vector to integer. Meaning for x and y, we only have integers like 0 and 1. I want to create a vector to integer where we have x and y. These values are going to be the rounded value of the current direction dot x and the current rounded value of direction dot y. Also, this should be direction dot x and y. Let's print what we're getting from that. So I want to print the face direction, and then inside of the player, call animate along with delta, which we're getting from the parameters. Make sure you are saving everything so Godot stops complaining. That looks good. And if I now run the game, I can go right, left, up, and down, and I'm getting the facing direction. And these numbers are very easy to work with because we either have 0, 1, or -1. These values we now have to map to the right facing direction. And this is quite easy because if you look at data, there we have the character view directions, where for example for vector to I and down, we have the integer value of 0. This 0 refers to, if you look at the character graphic, 0 would be the down-facing animation, and this is what we are using here. Left would be 1, right would be 2, and up would be 3. So we have 0, 1, 2, and 3. And besides that, we are getting the 4 diagonal directions and a default value. This one is more of a safeguard, but I guess it can't hurt. That means, once we have a facing direction, I can get the sprite 2D, and on there, update the frame coordinates.y. The value I want to assign to it is going to be data.characterViewDirections with the face direction. If I now run the entire thing again, I can go left, right, up and down, and we are getting at least the right direction. Not perfect yet, but definitely progress. And just to explain how this is working, if you look at this character, for the animation, we have 4 H frames and 4 V frames. And via the frame coordinates for Y, we can get the default looking down. If I set this to 1 or 2 or 3, then we're getting the 4 different directions. And this we are doing dynamically in code with these 2 lines. To animate it, I am going to need one more variable. All the way at the top, I want to have a var current H underscore frame. This one is going to be a floating point value that we are going to use to pick the frame coordinates.x value. So what I want to do is current H frame plus equal data.animation speed multiplied with delta time. That means this value is going to increase permanently. And then, after this if statement, I want to get the sprite 2D again, update frame coords.x, and assign it to the current H frame. Although this is not going to work yet, because frame coords.x wants to have an integer, which current H frame is not. That we can fix quite easily by assigning it to an integer. And by the way, this needs to be a float because of this line. Delta time is going to be a very small number, and we want to capture that. If current H frame was an integer, it would be lost. That's the first problem. The second problem is that the max value of frame coords x is going to be 3. Because we only have 4 frames in total, with 0 being the first and 3 being the highest. This number, however, is going to increase permanently. To limit it, I want to add mod sprite 2D and then get the H frames. That way, we can never exceed the H frames, so the animation is pretty safe. And that is pretty much it. If I now run the entire thing again, I can run around, and I'm getting the walking animation. The only issue is, if I stop walking, we are stuck on this frame, which sometimes is alright, but very often doesn't really work. The fix for that is going to be quite simple. If we don't have a direction, so else, then I want to set the current H frame to 0. And now I can run around and the player stops in the right animation frame. That looks pretty good, so I am quite happy. Oh, and by the way, I forgot to mention, in my case, for debug, I do have visible collision shapes, which you might not have. So in your case, the entire thing might look like this, which is pretty much the same thing. This still looks alright, although we do have to get rid of this character. Cool, with that, we have the very basic player setup. Besides the player, we're going to have a whole bunch of trainers. For those, we are going to use the character class again, and fundamentally a trainer is going to stand in place and look around. If it sees the player, it should stop the player and walk towards it. Once it reaches the player, we should start a dialogue. And this dialogue can also be started once the player talks to a trainer. For all of that, we are going to need a dialogue system, but that's going to come later. Let's do it step by step. The first thing that I want to do is go to scene and create a new inherited scene, where the parent scene is going to be characters and character, which I want to rename to trainer. Save this one inside of the same folder, and then to the level, I want to add a trainer instance. Let's move it vaguely here. And now, if I run the script, we have the player and a trainer, which doesn't do anything at the moment. Also, what we should be doing inside of objects and ordering, I do want to have YSort enabled. This should also be the case for characters. So in there, ordering, YSort enabled. That way, at least we have the right height for every single sprite. Looks pretty good. Also, while we're here, for each trainer, we can now set a character style. Let's go with the green character. This should be working already, and it does. That looks alright. First of all, for the trainer, I want to add a plain node that is going to be for timers. To that, for now, I want to add a plain timer node that is going to be renamed to watch timer. I have set the wait time of 4 seconds, and this should auto start. That's all we need for nodes. Next up, for the trainer, I do want to have a unique script. I do not want to use the parent one. So get rid of the current script, add a new one, the defaults are fine, and after create, I want to extend a character instead of a character body 2D, like we have done for the player. That way, we're getting all of this logic, while also being able to add more to it. For now, all I want to do is the watch timer is going to get a signal for the timeout. Every time this timer triggers, this player should be looking in a different direction. Which means I want to get a variable called view_direction, which doesn't exist at the moment. I want to go to the parent class and then create a var view_direction, which is going to be a vector to integer. Via this, we're going to track if the character is looking left, right, up, or down. Once this timer times out, I want to update this value to something random, which means I want to have an array with vector to I dot left, vector to I dot right, vector to I dot up, and finally vector to I dot down, the 4 possible directions. From these values, I want to pick one at random, which we can do by adding pick random. Once we have that, I want to update the sprite 2D and get the frame coordinates.y like we have done for the player. Since we now have 4 values, we can once again use the dictionary to get the correct y value. Just as before, I want to get data and character view directions. On there, I want to get the current view direction, and that should already do something. If I now run the script, the trainer should update after 4 seconds, and that works. This also works multiple times, so that is looking pretty good. Final attempt. We might have gotten the same value, but now we have gotten a different one. Perfect. With that, the character can look in different directions, but this at the moment is just a graphic. It doesn't actually do anything. To make it do something, we have to check if the character is, for example, looking towards the player, then we want to get the player. For that, we will need another node. To the character, I want to add a Raycast 2D. This will track if the trainer can see the player. To see it inside of the game, I want to go to debug and visible collision shapes. Then we can see the Raycast node, and that is working pretty well. When the trainer is doing all of this, I also want to update the Raycast node, which means Raycast 2D, and then we want to get the target position. The value for this one is going to be the view direction multiplied with the distance. Let's call this one the view distance, which does not exist at the moment. To fix that, inside of the character, I want to export a var view_distance. This is going to be an integer with a default value of 50. Let's try this one inside of the game. And now, once the trainer rotates, the Raycast should move along with it. And that works. Perfect. Although the same we should also do for the player. I want to work inside of the player and create another function. Let's call it update_view_direction. I only want to update the Raycast if we have a direction in the first place. If that is the case, I want to get the view direction and assign it a vector to integer with x and y values. I want to set y to 0 and x is going to be the rounded value of direction dot x. Once we have that, like we have done for the trainer, we can get the Raycast 2D node and update the target position. This is going to be the view direction multiplied with the view distance. Make sure to call update view direction, so update view direction. Then we can try this in the game. And we're getting an error. That is because I have a typo. This should be a capital C. If I now try the entire thing again, the game doesn't crash and I can look left and right. That works pretty well. That being said, we have two issues. We can't look up or down because the value for y is always going to be 0. Also, the view distance for the player is too large. That second issue is actually very easily fixable. If you go to level and select the player, there we have the view distance. For the player, this should be 20. If I now try this again, once we're updating the value, we are getting a much better result. So all we have to figure out is the y value, which is going to be another variable y that I want to use down here. I want to get the rounded value of direction.y, but only if direction.x is equal to 0. If that is not the case, else I want to get 0. Let's try this one now. If I walk around, then we are getting the right direction. If we are moving left or right, then the value for y is going to be 0. So we basically only get this value. However, if we're moving up or down, then the value for x is going to be 0. But for y, we are getting the rounded value. That way, we can only look in the 4 directions, so left, right, up or down, but we are ignoring all of the diagonal values. Those shouldn't be inside of the game. Let's continue working on the trainer. What I want to implement now, let me demonstrate. If the player walks here and gets seen by a trainer, then the player should be looking towards the trainer and the trainer should, after a short amount of time, walk towards the player. That's what we are going to create now. I want to work inside of the trainer and create a func_process in which we are going to check the Raycast node. Or in other words, inside of the trainer, I want to check if Raycast2D.getCollider is equal to the player. Now the player we don't have at the moment, but we can get it fairly easily. All we have to do is go to the player class and assign it to a group. Player. And then inside of the trainer, before we are doing anything, I want on ready var player is going to be get tree, get first node in group player. Make sure you're spelling this correctly. And once you have that, you have the player. And just for now, let's test what is happening. If this if statement triggers, I want to just print player. Let's try. If I now run into the Raycast, we are getting player. While doing that, also make sure that the Raycast for the trainer can only see inside of the collision mask the player itself, which is on layer 2. Actually, while saying that, I think I didn't actually implement collisions. So with the trainer selected under collisions, they should be on layer 3 for characters. They can see the terrain and they can see the player. Then for the player, inside of the collisions, the player should be on layer 2. And for the mask, we can see the terrain and we can see other characters. For the Raycast 2D node of the player, we only want to see trainers and nothing else. That way the entire thing is just a bit cleaner, but in practice it should give us the same result and that looks pretty alright. Cool. Now the trainer can see the player. Although this I only want to happen once. So at the moment, this if statement triggers on every single frame of the game, which isn't ideal. To fix that, inside of data, I want to create a variable called current character. This has to be a type character. So it either has to be a trainer or the player itself, which can't really happen, so this is always going to be a trainer. Make sure you're saving data.gd inside of the trainer. I also want to check and not data.currentCharacter. Once we are inside of the if statement, I want to overwrite the current character and assign it the trainer itself, so self. With that implemented, we are only going to see player once. Let's try. I can now run in there and we can see player once. That works quite well. If that is the case, then I want to start a timer, which we have to create. So inside of timers, I want to add another timer. This is going to be a walk wait timer. Inside of the if statement, I want to start this timer. The timer itself should be one shot and have a wait time of, let's say, 0.5 seconds. Once we have that, we can get the signal of the timer, so timeout and connect. And inside of this function, we want to get a direction, which ideally is going to be a get character direction and then to a target, which in our case is going to be the player. Now this get char direction doesn't exist yet, and we are going to use it for the player as well. As a consequence, it's going to be inside of the parent character class. Let me minimize everything, we don't need it. And I want to create a func get character direction where one parameter is the actual character. I most importantly want to get a direction between the character itself, in this case the trainer, and the target character, which currently is going to be the player. To get that direction, we just need the very basic vector math formula of target minus starting position. Or in other words, we want to get the character dot position and subtract self dot position, or just position. The return vector we want to normalize, and the entire thing we then want to return. So return, and this has to be a vector to integer, where we are getting the rounded value of direction.x and the rounded value of direction.y. And to be extra clean, this function should specifically return a vector to integer. Now at this point, Godot is complaining because char is an inbuilt function, which is not ideal, so let's rename it to target character. Then Godot should be happy, and it is. Perfect. Now, just to test things. After we are calling this function, I want to print the direction. Also make sure you're saving the parent scene, then Godot should be happy everywhere. We don't need delta at the moment as well. So now, let's try. And after we are in there, after half a second, we are getting the direction. This is only going to work once because we do have a current character inside of data. So let's try it once again. If I am now in a different position, let's wait a second. This should be 1 and 0, and it is. Perfect. With that, we know in what direction the trainer has to go in, which we can use inside of process. I want to check if this trainer has a direction. If that is the case, I want to animate with delta like we have done for the player. As a reminder, this function comes from the parent class. We are using this animate. Besides that, we want to move the trainer. If I now run all of this again, I can go here, and after half a second, the trainer is moving down in the player direction. Good start, but this needs to be refined. Most importantly, before we are doing the movement part, I want to check if position and distance to the player position is smaller than a certain value. I found that 24 is a pretty reasonable number here, which should be a variable. Export var stop radius, and this is going to be 24, which I guess should always be an integer. This value we want to use down here, stop radius, and if that is the case, I want to set direction to a vector2.0 and then print show dialog, because this is effectively what we want to do. If I now run all of this again, the trainer walks towards the player and then stops. Although you can see the walking animation is still there. That is because we do not call animate anymore. Now you could add an else statement and call it again, but I think what is going to be easier is to simply target the sprite 2D of the trainer and set the frame coordinates.x to 0. That way it looks like the trainer is standing still. Let's try this one, and let's try a different direction as well. So should happen any second now. There we go. And if I now wait, the trainer walks towards me and then stops. We also get show dialog. That is looking pretty good. That means we just have to add a couple of minor things. The first one is that once the trainer has seen the player should stop looking around. Or in other words, if I am waiting for the update for the movement, if I go up here, then the trainer should keep on looking at the player and not look in random directions. I want to have another variable called look_around. This is going to be a Boolean value that by default is going to be true. And this, I guess, we could also export, so you can toggle if a trainer is looking around in general. And then, inside of process, I want to check if the Raycast is colliding with the player, if we have a current character, and if the trainer is looking around. If, however, the trainer has seen the player, then look around should always be false. Besides that, when we are getting the onWatchTimerTimeout function, we only want to do all of this if look around is true. Which means now, if I get into the view of the trainer shouldn't be looking around anymore. And that looks pretty good. Besides that, once the trainer has seen the player shouldn't be able to move anymore, which means we have to work inside of the player. Fundamentally, in here, I only want to allow get input if not data and current character. If there is a current character, then we want to get other kinds of input. We're going to work on that later. But for now, if that is not the case, else, meaning we do have a current character, then I want to set direction to a vector2.0. That should be it. If I now walk into the view of the trainer, the player cannot move anymore. That works. The last thing that I want to work on is that when the trainer sees the player, I want to change the view of the player. In other words, the player should look towards the trainer. For that, we will need a direction that we already have from getCharacterDirection, in which we want to get data.currentCharacter. The one thing that we have to create is change view. This we want to reuse later on, so it's going to be inside of the parent class. I want to have func_change_view, which gets a target parameter that is going to be a vector2. In there, all I want to do is get a sprite 2D, update the frame coordinates.y, and get, once again, data character view directions, where the key is going to be the target. That's the same dictionary we have used before. Inside of data, we are once again using all of this. It's surprisingly useful. I can try the entire thing, and the game is crashing. That is because this parameter needs to be a vector2 integer. Next attempt. Now the player is looking towards the trainer. Let's try it again for a different direction. For that I have to wait for the trainer. Shouldn't take too long. And now Once again, the player is looking at the trainer. That works really well.